So good morning students. So in 7th A group elements, halogens, some what are periodic properties or some physical properties are completed. The next one is oxidation numbers. It is oxidation numbers of 7th group elements. Actually 7th group elements exhibit, okay, 7th group elements exhibit -1, +1, +1 to +7 oxidation numbers. -1 oxidation number, +1 to +7 oxidation numbers. So if gain of electron, negative oxidation number. If lose of electron, positive oxidation numbers. So now first ground state. What is a ground state? So ground state electronic configuration is what is NH2 NP5. What is NH2 NP5? So NP, it is NP, it is NP. So NP2 NP2, it is NP1. So total it is NP5, NH2 NP5. So now wherein oxidation number is -1 or +1, -1 or +1, lose of 1 electron or gain of 1 electron, ground state. So now first excited state. What is the first excited? What is the first excited state? So now an electron transition from what is a P to D. What is a P to D? So now NH2 NP2 NP1 NP1 ND1. What is a ND1? So now 3 unpaired of electrons. So now oxidation number is +3. It is oxidation number +3. So wherein hybridization in first excited state is sp3d. What is sp3d hybridization? So the hybridization is sp3d hybridization. Now second excited state. Second excited state electronic configuration is NH2 NP1, okay, NH2 NP1 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 ND1 ND1. So it consists of how many valence unpaired of electrons? 5. So now oxidation number is +5. Hybridization is sp3d2. What is sp3d2? Okay, sp3d2. So now third excited state. Third excited state. So now NS1 NP1 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 ND1 ND1 ND1. So total number of unpaired of electrons is 7. So the oxidation number is sp +7. Hybridization is sp3d3. What is sp3d? Now in sp, or actually in ground state, no hybridization. What is no hybridization? So no hybridization. Okay, no hybridization. So the shape of the molecule is a linear shape. That is the shape of the molecule is a linear shape. But in first excited state, hybridization is sp3d. The shape of the molecule is a T shape. What is a T shape? So in second excited state, hybridization is sp3d2. Shape is square pyramidal. square pyramidal. What is a square pyramidal? So now in third excited state, oxidation number +7, hybridization is sp3d3. So shape is pentagonal bipyramidal. What is a pentagonal bipyramidal? So these are the oxidation numbers, hybridizations, and the shape of the molecules. So these are the oxidation numbers. So now after completion of general properties of halogens, then next one is chemical properties. What are chemical properties? Chemical properties of halogens. So halogens with more electronegativity values. So then its chemical reactivity is more. So chemical reactivity more. So halogens are more reactive. What is more reactive? Because it's high electronegativity values. What is high electronegativity values? So now halogens react with mainly what is a hydrogen. So now reaction with what is reaction with hydrogen. Okay. So now second one is reaction with water. What is reaction with water? Third one is reaction with metals. What are reaction with metals? Reaction with metals. Fourth one is reaction with oxygen. What is reaction with oxygen? And the reaction with halogens, interhalogen compounds. So fifth one is reaction with what is halogens. What is reaction with halogens? These are the chemical properties of halogens, or seventh group elements. Now first one is reaction with hydrogen. So now in chemical properties, first one is reaction with hydrogen. So it gives hydrogen halide. Halides. What are hydrogen halides? So now first one is reaction with hydrogen. That is a reaction with hydrogen. So simply halogens are represented with X, and these are the diatomic molecules. So they wherein X2 or X equal to what is fluorine, chlorine, bromine, iodine. So astatine is the radioactive substance. So now halogens X2, okay, X2 react with H2 hydrogen. It gives HX type of hydrogen halides. HX type of hydrogen, XX type of hydrogen halides. Okay, HX type of hydrogen halides. So for example, F2 plus H2 gives rise to 2HF. What is it? 2HF. So it is a hydrofluoric acid. So it is the weak acid. It is a weak acid. Weak acid. So for example, Cl2. What is a Cl2 plus H2 gives rise to 2HCl. Same as HBr. Same as what is a HI. So it is a reaction with the hydrogen. So next one is a reaction with water. Second one is reaction with water. Reaction with water. So now halogens, what are X2 plus H2O. What is H2O? So then it gives what is HX type of hydrogen halides plus HOX. What is HOX? So now X2 plus H2O gives rise to HX plus HOX. Hypohalogens. halides. So these are the hypohalides. That is the hypohalides. These are the hydrogen halides. Hydrogen halides. So for example, F2 plus HOH, H2O gives rise to, it is HF, hydrogen fluoride, plus HOF, what is HOF. Similarly, Cl2 plus HOH, hydrogen plus OH group. So then it is HCl plus HOCl, like that HOBr, like that what is HI. So it is a reaction with water. So next one is reaction with oxygen. So third one is reaction with oxygen. So generally, mainly fluorine or chlorine react with oxygen, it gives corresponding oxides. What is corresponding oxides? For example, X2 plus O2 gives rise to what is OX2 or O2X2 type of halides. So simply X2 plus 2O2, X2 plus O2 gives rise to OX2, it is 2. So then it is 2X2. 2X2 plus O2 gives rise to 2OX2. So simply OX2 type of halides mainly OF2, like that OCl2. So these are the O2F2. What are O2Cl2? So same as Cl2O, okay, Cl2O, Cl2O3, Cl2O7, like that. These are the oxides. What are these? Are oxides. So wherein OF2, oxygen difluoride, wherein fluorine oxidation number is -1, fluorine oxidation number -1, oxygen oxidation number is +2. So due to fluorine with more electronegativity comparatively oxygen. So then each fluorine -1, two fluorines -2, oxygen is +2, like that. So now in O2F2, fluorine is -1, oxygen also what is +1 oxidation numbers. So next one is a reaction with the